everyone. So in the previous lecture we have discussed about the RL circuit, first order RL circuit concepts, and I have told that you have to follow the 4 to 5 steps to solve the problems based on the first order RL circuit. As we have done in case of what? RC circuit, in the similar way we will do the problems based on the RL circuit. And here we go. This is the first question. It is asking about find the value of ILT for t greater than 0. Okay, so it is asking about the response within the inductor. So we have to follow all those 4 steps. Okay, so step number 1 is what? What is the step number 1? That is to calculate the value of t is equal to, at t is equal to what? 0 minus. So step 1 is what? At t is equal to 0 minus, what will happen? At t is equal to 0 minus, what will happen? Inductor will have like a short circuit. And what is the switching action? The switch is getting open after t greater than 0, after t is equal to 0. That means at t is equal to 0 minus, this switch is closed. So switch is closed, inductor is short circuited. We will find the value of IL0 minus, and IL0 minus from this circuit you can easily calculate. This is equal to 10 divided by 2, that is equal to 5 ampere. Why? Because this resistance will be shorted with this. Okay, so there will be no resistance here. Okay, so 10 divided by 2, that is equal to 5 ampere. Now the next one is what? To get the value of IL infinite, and to get the value of IL infinite we will find the value of IL infinite at t is equal to infinite. What will happen to the circuit? At t is equal to infinite, switch is what? Switch is getting open and the inductor will have like a short circuit. So I have drawn the circuit for IL is equal to infinite. What will happen? Now the current will be 10 divided by, this is open now, that means total resistance will be 3 plus 2, that is 5. How much it will be? That is 10 divided by 5, that is equal to 2 ampere. So step 1 is over. Now the step 2 is what? To get the value of time constant, and time constant is equal to L equivalent divided by RTH, and it is always calculated for t greater than 0. Now the circuit for t greater than 0 is what? This is the circuit for t greater than 0, but now don't make it short circuit inductor. Okay, so this is the circuit for what? T greater than 0, and we know that while calculating the time constant, all the independent voltage sources will be short circuited, all the independent current sources will be what? Open circuited. So finding the time constant L equivalent and L equivalent divided by RTH, it is always found after switching or t greater than 0. Voltage source will be short circuited, current source will be what? Open circuited. If you do so, what you will get? You will get like this circuit. This source has been shorted, this is L, this is across this terminal. If you find the RTH, what will happen? 3 plus 2 will be in series, that is equal to 5 ohm, and L equivalent is already known, that is equal to 1 by 3 Henry. So tau is equal to how much? L equivalent divided by RTH, that is equal to 1 by 15 second. Now the next step is what? To get the value of ILT that has been asked in the problem, and ILT we know that is equal to IL infinite, IL0 minus IL infinite e to the power minus t by tau. Put all the values calculated. IL0, IL infinite is equal to 2, IL0 minus is 5, and tau is equal to how much? 1 by 15. You will get the answer 2 plus 3 e to the power minus 15t. Hence option B is what? Correct. So there is no difference for the calculation purpose. In RC circuit, what we have done, we are also doing in the RL circuit, but everything is replaced with the current. Okay, here the time constant is L equivalent by RTH. In RC circuit, the time constant was RTH into C equivalent, but procedure will remain same. The C circuit will be have at t is equal to 0 minus and t is equal to infinite as open circuit, but L behaves like a short circuit at t is equal to 0 minus and t is equal to infinite. So the first problem is over. Now moving to the next problem. What is the next problem? Find the value of IT for t greater than 0 plus in the given circuit. You can see what now we have to calculate. We have to calculate this IT, and IT is not part of the inductor current. That means in step number 5, I have told that whenever some different responses has to be calculated, first we will calculate what? the current flowing through the inductor. Okay, first you will calculate the value of ILT using this expression, IL infinite plus IL0 minus IL infinite e to the power minus t by tau. Then after calculate the other response what has been asked. So forget about IT, just calculate the value of ILT in the given figure. Okay, what is the switching action? At t is equal to 0 minus, this switch is what? Open. At for t greater than 0, this switch is what? Closed. So first case, step 1 in first case, that is t is equal to 0 minus, this switch will be what? Open circuited. Switch is open circuited. Next, inductor will be short circuited. If you calculate this IL0 minus, what you will get? This current will be 0 because it's open. Okay, this is a current source, there is this resistance and there is this resistance. These two resistances are in parallel. This current source current will divide equally. Why equally? Because this is 10 ohm, this is 10 ohm, so equally division, you will get 1.5 divided by 2, that is equal to 0.75 ampere. So IL0 minus will be 0.75 ampere. Now case 2 is what? At t is equal to infinite, what will happen? Switch is what? Closed. Switch is closed now. Okay, inductor is short circuited. Now the IL infinite, you can easily calculate. What is this one? 10 10 10, these three equal resistances are in parallel and this is a current source, so the all currents will be divided equally. How much you will get? That is 1.5 ampere divided by what? 3, that is equal to 0.5 ampere. So step 1 is over. We have calculated the value of IL0 minus and IL is equal to infinite. Okay, now the next step is what? Finding the time constant of the circuit. So next step is what? To get the time constant of the circuit, and we know that the time constant is always calculated for what? For t greater than 0. All independent voltage sources will be short circuited, current sources will be open circuited. So if we do so, this is the current source was here, so it will be open circuited. This is 10 ohm, switch is closed, this is 10 ohm, this is 10 ohm, this is 15. Now calculate the RTH from here. What you will get? These two are in parallel, then whole combination will be in series with what? 10 ohm. So you will get that is equal to 10 in parallel 10 plus 10, that is equal to 15 ohm. Okay, and L equivalent is already given to you, that is 15 into 10 power minus 3 Henry. So tau will be that is equal to 10 power minus 3 second. Now the next step is what? To get the value of ILT, and we know the formula IL infinite plus, this is the formula for ILT. We have already calculated this value and this value. Put all these values here, you will get ILT is equal to what? That is 0.5 plus 0.25 e to the power minus 1000 t. Okay, but in this question it is not asking about ILT, it is asking about the IT at for t greater than 0. You can see for t greater than 0, the switch is closed. The switch is closed. This is the current that has been asked. This is IT. Okay, this one is 10 ohm. This is 15 millihenry. This is 10 ohm. This is 1.5. This one. Now you know the value of ILT, that is equal to this amount. Okay, we have to calculate IT. Okay, now see, you can see here, this voltage and this voltage will be same, and this voltage from this point to this point, this voltage, this voltage, this voltage and this voltage, all voltages are equal to what? V1. Okay, so tell me, can I apply here nodal analysis? Can I apply here nodal analysis? You can apply nodal analysis. How you will apply the nodal analysis? This is the voltage V1 divided by what you will do? This resistance, this resistance. Okay, you will never count this resistance because I am putting this ILT equal. Okay, so if we want to do in more easy method, we can say that this voltage is V1, this is also V1, so we can say that this current and this current will be equal to V1 divided by what? 10 ohm. That is equal to equation 1. Now apply the KCL at node A. What you will get? This current is incoming current, so this will be minus 1.5. This current is outgoing, this current is also outgoing, this current is also outgoing. So I1t plus IT minus 1.5 plus ILT is equal to 0. We have to calculate the value of IT, and we know that I1T is exactly equal to IT. So 2IT is equal to 1.5 minus ILT. So IT is equal to 1 divided by 2, 1.5 ILT, and the ILT value is how much? This much amount. Put this value and you will get the value of what? You will get the value of what? That is equal to option A is correct. Okay. So we have calculated the value of IT by using the value of ILT. Okay. So whenever other response is asked, our first step to calculate the response in the what? L. Okay. Then after we will move for the other responses. Now moving to the next problem. What is the next problem? In the circuit shown below, the switch is initially at position 1. Switch is initially, that means at t is equal to 0 minus, switch is at 1 position. For t greater than 0, the switch is at what? 2 position. Okay. So it is asking about the current I through the inductor. The current I through this inductor we have to calculate. Okay. So to get the value of I in this inductor, to get the value of I, what we will follow? It is asking about the current flowing through the inductor, and we know the formula to get the value of current flowing through the inductor, that is IL infinite plus IL0 minus IL infinite e to the power minus t by tau. Is it okay? So step number 1, at t is equal to 0 minus, what we will do? At t is equal to 0 minus, the switch will be at this position. This circuit has been removed. The switch is at this position. Okay. This will be shorted. This is 10 ohm. This is 10 ohm. Okay. What you will get? This circuit will look like this. Is it okay? Like this. At one position. This has been removed from here. How much this current will be? 10 divided by 10. That is equal to how much? That is equal to 1 ampere. At t is equal to infinite, switch is at 2 position. This will be shorted. What is the value of IL infinite? That is equal to, this is 4 ampere, this is 10 ohm, this is 10 ohm. Two resistances are in parallel with this current source, so equal division will be there. This is 2 ampere, this, and 2 ampere will be this one. So IL infinite will be 2 ampere. This current will be 0 because this is open circuited. Now next step is what? To get the value of time constant, and it is always calculated for what? T greater than 0. All the independent voltage sources will be short circuited, current sources will be open circuited. This is the circuit for t greater than 0. All the independent sources will be deactivated. This will be open, this will be shorted. Okay. And this is L. So how this circuit will look like? This is open, this is shorted, this is 2 position, this is L. Now find the RTH from here. You can easily see here this 10 and this 10 is in series, that is equal to RTH is equal to 20. If RTH is equal to 20, L equivalent is already given, that is equal to 1 Henry. So tau is equal to how much? 1 by 20 second. Okay. Now the next step is the final step, that is to get the value of inductor current. You know the formula. This one, you know all this value, this value, this value, and this tau value. You just put it here. You will get 2 minus e to the power minus 20t, and this is what? The option D is what? Correct. Okay. So what you are concluding here? What are the steps you have followed in RC circuit in the similar way I am doing for RL circuit? But what is the change is that is the expression has been converted into its current equivalent, but in RC circuit the expression was in what? Voltage equivalent. Here the inductor is shorting, there the capacitor was open circuited. Okay. Time constant was there, that is RTH into C equivalent. Here the time constant is what? That is L equivalent divided by RTH. And while finding time constant, it is always found at what? T greater than 0. So if you follow these steps, every problem you can solve very easily. Okay. Now moving to the next problem. This is the fourth one. What is it is asking about? In the circuit shown in figure, the value of V naught T for T is infinite will be. Okay. So what is the problem? It is saying that this is the circuit. You have to calculate this V naught T at what? At T is equal to infinite. Okay, if you want to calculate v naught t, what you have to do, you have to know about this, the current flowing through 5 ohm resistance. That means if we know this current ix at t is equal to infinite, we can easily find the v naught t at t is equal to infinite. How? That is 5 multiplied by this ix value at t is equal to infinite. You will get the v naught t at what? At t is equal to infinite. Okay, this one is plus and minus. Okay, so it is not asking about vt or it for t greater than 0. It is asking about exactly at t is equal to infinite. So we will draw the circuit for exactly t is equal to infinite, and at infinite we know that inductor will have what as a short circuited. So make it short circuit. What is this function? This is 10 ut, and ut at t is equal to infinite, that is equal to 1. So this will become only 10 ampere. Is it okay? So if you make the circuit at t is equal to infinite, the circuit will look like this one. Is it okay? The circuit will look like this one at t is equal to infinite. Now you can easily calculate this v naught value, and we can say that how you can calculate this v naught value. You just apply one nodal here. What you will get? v1, this is the nodal voltage v1 bracket. What is the resistance? Self resistance is 1 by 5. This is also 1 by 5. Okay, 1 by 5 plus 1 by 5. There is no mutual nodes. That means is equal to, this one is what? Incoming current 10 plus 10. Then this one is positive is connected here. So positive 2 ix divided by what? 5. That is equal to equation number 1. But we have to calculate the value of what? V naught. This v naught value is exactly same as v1. Both are in parallel. Okay, so we have here ix. You have to remove this ix, and we can say that ix is equal to this voltage divided by what? 5 ohm. We can say that v1 divided by 5 is equal to what? Ix. So using this equation and this equation, you can get the value of what? V naught, and V naught is equal to, if you do calculation V naught, you will get 31.25 volt. Okay, so as it is asking about t is equal to infinite only, so we are calculating the values at t is equal to infinite only. We are not interested in finding the it for t greater than 0, or the general expression of it for t for any value of the t. Okay, the next problem is what? What is this problem? The voltage Vt shown below is applied to the given circuit. Okay, this is the input voltage, and its waveform has been given here. See here, before t is equal to 0, what is happening? The voltage value is 3 volt. After t is equal to 0, the voltage value is how much? That is equal to how much? That is 6 volt. This is 6 volt. This is how much? 3 volt. Okay, so it is asking about the IT current at t is equal to 1 second. Okay, you can see this is first order circuit. Okay, you have to calculate this IT, that means inductor current. So we will, what we will do, we will do all those 4 to 5 steps to get what? The value of ILT. Step number 1, at t is equal to what? 0 minus. What is happening? At t is equal to 0 minus, what will happen? Vt value is how much? That is equal to how much? 3 volt. So this will be 3 volt. Inductor will be shorted. Inductor is shorted. Can you find this current I0 minus? You can easily find this current. What you can do? What you can do? You can either apply nodal here, or you can get this current I value. I0 minus, that is equal to, first you calculate this current I. Okay, how much this current will be? How much this current will be? 3 volt divided by total resistance. Total resistance will be 1 and 1 will be in parallel, plus what? 1. You will get what? 3 divided by 1 plus 1 in parallel. 1 plus 1, that is equal to 2 ampere. Now this 2 ampere, if it is 2 ampere, this is same resistance, equal current will flow. This will be 1 ampere, this will be 1 ampere. So I0 minus will be 1 ampere. Or you can do, write a nodal here. You find this voltage. This voltage will be same as this voltage. You will get what? The value of what? I0 minus. If we apply nodal here, see here, you can apply nodal here also. see here, what you will do, take it this V1, so V1 1 by 1, 1 by 1, next 1 by 1. Is it okay? These are the three resistances is equal to, this one is positive, is connected to this terminal, so 3 divided by what, 1, so V1 how much you will get, 1 volt I guess. Okay, and this voltage is same as this voltage, so I0 minus will be what, 1 divided by what, 1, that is equal to how much, 1 ampere. So you can do in any manner. The next step is what, the next point is what, at t is equal to infinite, what will happen? At t is equal to infinite, the voltage value is getting what, 6 volt, and this is 6 volt, that means it is 6 volt, this is 1, this is 1, this is 1, again you will get the same value, again you will get what, this is 6 volt now. Okay, so write nodal here, again you will get the value of what, V1, and V1 divided by 1 you will get the value of what, I infinite. Or you can do, find this current will be how much, 6 divided by 1 plus, these two are in parallel, 1 into 1 divided by 1 plus 1, you will get 4 ampere, and this 4 ampere will be divided equally, this is 2 ampere, this is 2 ampere, so I infinite will be how much, that is equal to 2 ampere. Okay, now the next step is what, finding the time constant of the circuit. If you do, the time constant is always found for what, t greater than 0, draw the circuits for t greater than 0, but all the independent sources will be deactivated. Voltage source, there is voltage source, okay, 6 volt of voltage source, you will get short circuited, this is 1 ohm, this is 1 ohm, this is inductor, this is 1 ohm. Okay, across this terminal AB, if you find the RTH, what will happen, these two are in parallel, then whole combination will be in series with 1, what will happen, 1 in parallel 1 plus 1, that is 1 by 2, that is equal to 1.5 ohm. Okay, L equivalent is already given, that is 1.5, so tau is equal to how much you will get, that is 1 second. Now the finally the value of IT you can easily calculate by using your basic expression. You know this value, you know this value, you know this value, put all these values, you will get IT is equal to 2 minus e to the power minus t ampere. But it is asking about IT value at t is equal to 1 second, so put t is equal to here 1 second, you will get 2 minus e to the power minus 1. If you calculate this value, you will get 1.632 ampere. Okay, so moving to the next problem. What is the next problem? The circuit shown attains a steady state with the switch S is closed. When switch is closed, with switch S is closed, what is the value of IT for t greater than 0 if the switch is opened? That means before t is equal to 0, switch is what? Closed, and after t is equal to 0, switch is what? Getting open. It is asking about the value of what? IT. IT means inductor current. We will follow the same step again. What you will do is step 1, at t is equal to 0 minus, what is happening? T is equal to 0 minus, switch is what? Closed. Switch is closed. This is what? 20 volt. This is what? 10 volt. This is what? 20 ohm. This is what? Inductor will be shorted na? At t is equal to 0 minus. Okay. Now we want to calculate this current. You can see this polarity is A, this polarity is C. I have assumed this is A, this is C. You can see, take it as B. You can see this point, this point, this point will be same. So this polarity is also B. Similarly, this point, this point, this point, all points are same, short circuit points. So this is C. So can I say that if we want to calculate I0 minus, can you calculate this current? Can you calculate this current? Yes, we can calculate. How you can calculate? This current will be this voltage VAB divided by what? 30 ohm. VAB divided by what? 30 ohm. And VAB will be how much? You see, this is AB, this is also AB. That means both are in what? Parallel. If both are in parallel, voltage will be same. That means this is 20. So 20 divided by 30, that is equal to 2 by 3 ampere. Similarly, if you see, this is VBC, this is VBC, this is what? BC. This and this one in parallel, that means this voltage and across this voltage will be same. So here will be also 10 volt, and this current will be how much? 10 divided by what? 20. 10 divided by 20, that is equal to how much? You will get 1 by 2. I have to calculate this I0 minus. I know, just take this voltage, that will be same as BC. This is BC and this is also BC. That means two are at same potential. If same potential there, if this is 10 volt, this will be also 10 volt. So current will be how much? 10 divided by 20, that is equal to 1 by 2. If in the exam this current is asking at this position, you can how to, this is AB, this is AB. The AB voltage is 20, so this will also be 20. If this is 20, 20 by 30, you will get what? I1 value. Okay. Now case 2, at t is equal to infinite, this switch is what? The switch is now open, L is shorted. If you draw the circuit, what you will get? If you draw the circuit, what you will get? You will get something like this. At t is equal to infinite, switch is open, this is 10, this is 20, this is I infinite, and you can easily say there will be no current here. That means this I infinite will be 10 plus 20 divided by 30 plus 20, that is 50. How much you will get? 3 by 5 ampere. Now the next step is what? To get the time constant, it is always calculated for what? T greater than 0, and all the independent voltage sources will be shorted. So this will be shorted, this will be shorted, this will be open, because it is calculated at for t greater than 0 and switch is open for t greater than 0. So how the circuit will look like this one. So across this terminal, if we calculate the RTH value, what you will get? 30 plus 20, that is equal to 50 ohm. L's value is 1 Henry, so tau will be 1 by 50. And finding IT, and IT you can easily find now. I infinite, this value, and this value. You put all the values, you will get 0.6 minus 0.1 e to the power minus 50 t ampere, and the option B is what? That is correct. Okay. Now the seventh one is what? What is the seventh one? Determine the values of Ix, Iy at the steady state for the given circuit. See, Ix, and this is Ix, this one is Iy. We have to calculate the value of Ix and Iy at a steady state condition. At a steady state condition, inductor will behave like a short circuit, capacitor will behave like a open circuit. So as we are not here interested in finding the Ix and Iy for t greater than 0, it is exactly asking at steady state condition. So capacitor will behave open circuit and inductor will behave what? Short circuit. So just draw the circuit. What will happen? This inductor will be shorted, this will be open, this will be shorted, this will be open, this will be what? Shorted. You just make this circuit, it will look like this one, like this. Okay, this one is Iy, this one is what? Ix. Now what we can do, you can see this voltage will be same. So we can say that this node voltage will be what? How much? 5 volt. So I have written here that is equal to 5 volt. Next, Ix will be what? This voltage divided by what? 1. So Va divided by 1, that is equal to 5 by 1, that is equal to 5 ampere. Is it okay? Now this one is 1 ampere, this one is 5 ampere. You can get the value of Iy by writing a KCL at A. This one is incoming current minus 1, this one is outgoing plus Ix, this will be also incoming current minus Iy is equal to 0. So Iy you will get that is equal to 4 ampere. Is it okay? Okay, so next one is, this is the last problem under this category. It is asking about IL and VC under steady state condition for the given circuit. Okay, under steady state means this will be open, this will be open, this will be shorted, this will be shorted, this will be short. So at t is equal to infinite, switch will be closed. So drawing the circuit under steady state condition, how the circuit will look like this one. We have to calculate this IL, this is equal to VC. First of all, see, the current will flow from here, this one, there will be no current here, there will be no current will be here because these are open circuit. So this will be also, so in the whole circuit the current is flowing, that is equal to IL. So IL is equal to 10 divided by 1 plus 1, that is equal to 2, that is equal to how much? 5 ampere. Now this VC voltage is exactly same as this voltage, as the current is flowing, that is equal to 5 ampere. 5 into 1, that is equal to how much? 5 volt. So VC is equal to how much? That is equal to 5 volt. So this is all about for what? first order RL circuit, we have discussed all the concepts related to RL circuit and its problem based on the RL circuit. The conclusion is that whether it is RC circuit or whether it is RL circuit, the steps will remain same. Especially you have to focus on the time constant calculation, that is always calculated for t greater than 0 or always calculated for after the switching action. Okay, if other responses has been asked other than IL or VC, then always calculate for VC in case of RC circuit. In case of RL circuit, first calculate the ILT, inductor current, then after go for the calculation of the other response by using KVL, KCL and nodal analysis. So in the next lecture we will start our next topic, that is problems based on the t is equal to 0 plus instant. And really this topic is very nice and it has a very good weightage in GATE and ESE exam in comparison to first order RL and first order RC circuit. That means if we talk about the importance of the topics in the transient analysis, I guess t is equal to 0 plus conditions problems are very important more than RL circuit and RC circuit. Okay, so in the next lecture we will discuss all those things and definitely you will feel very good in those problems. Okay, so if there is any doubt, you just post it on our Facebook group, join it, that is no problem, GATE-ESE. Okay, and for more resources you just visit to our website www.gatenoproblem.wordpress.com. so everything we have done. Okay, thank you.